We're on page 3 of the notes here in 5.1, and I wanted to point out a couple typos for you. Sorry about that, but this is page 298, number 26 that we're going to look at, page 298, number 36, and finally 298, number 38. As you go through the assignments, a critical skill that you want to develop is to be able to ask the question, what's different, when the problems start to get more complicated or things don't turn out like you were expecting them to. It's a way to get your brain to realize that we're leveling up, we're challenging ourselves, we're expanding what we're learning. But we still essentially are using the same steps, which is why that it's so important to work out the steps, do the problems on the simpler ones like we did on page 2, so that when they get more complicated, you're ready for it. You have that habit in place already. Okay, so as we look at number 26, we may not notice what's different here. It feels just like we have two equations written in slope-intercept form, y equals mx plus b form, and we are still using the same instructions from the previous page. We're going to graph to find the solution to this system. So we look at how to graph this here, and we've got our beginning point, b equals 3, which is the y-intercept, 0, 3. This is for equation 1, this top one. And then we have our, our b of negative 1. Apologize. And then we have our slope of 3, or 3 over 1, which means we move up 3 to the right 1. Continue that slope pattern as many times as you need to, up 3 to the right 1, until you can get your graph confidently. And for the second equation, our b value is positive 2, which means our y-intercept is 0, 2. That's where we begin. And our slope is 3, or 3 over 1. Same slope as before. Up 3 to the right 1, up 3 to the right 1. You could go down 3 to the left 1, down 3 to the left 1. Those would all land you on the same line. And when you connect that, you notice that there's no solution here. The lines do not cross. And the mathematical description for that is the fact that they're parallel lines, the symbol of the two straight up and down lines to give that away, to express that. And what was the clue at the beginning that these were parallel lines? The fact that your m values were the same. Same slopes is what determines parallel lines. Same slope, different y-intercepts. So they are different lines, but they will not cross each other, so there is no solution. And you can just write that as such, no solution, or you can do the 0 with the slash through it to mean there's no point where these two lines intersect. For number 36, what's different about this one was similar to what we had before. We've got 1 in standard form of the equation, and again 1 in slope-intercept form. So we can use our two graphing methods that we gained from Math 60. And in standard form, usually it's easier to do the intercepts. So in equation 1 here, we'll put 0 in for x, 0 in for y, and see what happens. 2 times 0 minus y equals 0, and 2 times x minus 0 equals 0. And when you plug in 0 for x, you get 0 minus y equals 0. Y would have to be 0 as well. When you plug in 0 for x in the bottom equation, or for y in the bottom equation, 2x minus 0 equals 0. X would also have to be 0. And so you end up with only 1 point using this graphing method. And you should recall that this happened in Math 62, and what you would need is a third point. You could pick any value. We'll pick, oh, how about we put in 1 for x? So 2 times 1 minus y equals 0. You get 2 minus y equals 0. Negative y equals 2. Y equals negative 2. Sorry to run into the other. Sorry, y equals negative 2 when you move the 2 over, and then y equals positive 2. So you get the point 1, 2. So that's our third point on there to allow us to figure out what the line is. And we'll connect that with our black. That was our original color for equation 1. And then for equation 2, it is in y equals mx plus b form, where our b value is 0 and our m value is 2. So we'll use 0, 0 as our intercept, and right there we see that that's the connector, the intersecting point, the solution. What we also notice as we do our slope, we go ahead and graph that line, we go up 2 and over 2, and we end up on the same line. And as you refer back earlier to your notes, when you have the same line, that means there's an infinite number of solution, or infinitely many solutions, all that are on the same line. Any point on the line is a solution. So as you write that as set notation, you could say, the little French, they're not really French, but the little braces, little fancy, they look fancy. I think that's why I think they're French. But the point xy such that, that straight line means such that, and you can use either equation 1, 2x minus y equals 0, or you can write that as equation 2, little braces, xy such that y equals 2x. So that's what it looks like in set notation when you have the same line. Okay. And again, I apologize for running over into the next example here, but let's look at the third one. What's different about this one? Well, these are very different forms of the equation here. If you try the point method, it doesn't get you very far, and you might recall from Math 60 that when you see x equals a number, it's a certain type of line, and y equals a number is another certain type of line. X equals number, every x coordinate is 3. When you connect the dots there, you're always going to get a vertical line. And some of you might remember the hint of there's, looks like a little V sitting in there and inside the x. And for the y equals a number, every y coordinate is 5. And so as you look at that, the little hint, the y kind of looks like an H turned upside down, so that's our clue to remember that it's a horizontal line. So we can still graph these. We've just got 2 up and down lines here. X equals 3, if we make this equation 1, that is a vertical line right here. And then equation 2, y equals 5, that is a horizontal line. And those are going to cross right there at the solution, the intersection, at the point 3, 5, which makes sense. If we're saying that the system is x has to be 3, y has to be 5, there's our answer, x equals 3, y equals 5. The equations actually tell us what the answer needs to be. And again, in solution, or in set notation, put the little braces and put the point right inside of there.